So here, the last example, we did the graph, we did the domain and range. This example, we're going to look at an equation. And in the equation, it says determine an equation of the inverse. So to determine the equation of the inverse, we start the same as everything else by switching the x and the y. So our original equation was y equals negative x squared plus 4. Our equation is going to be x equals negative y squared plus 4. And then we're going to solve for our y value, get y by itself. So what we did yesterday at the beginning by practicing getting a new variable by itself, the reason for that is because after you've switched x and y, to find out what the equation of this equation is, you're going to want to get the y by itself. So what we can do is we can move the y squared over to the left by adding y squared to both sides, subtract x on both sides, and you'll get y squared equals negative x plus 4. So did you see what I did? I added y squared to both sides, and I subtracted x to both sides. The reason I did that is so that I could get the y by itself and to have it positive. How do you get rid of a square root? Oops, kind of gave it away. Let me rephrase that question. Anybody have any idea how to get rid of a squared? Square root, brilliant. So we'll square root both sides. You have to remember when you square root both sides to add the plus or minus. So this is the equation of the inverse. Sketch the graphs of both of them. So now we're going to use some of our skills with our transformations unit. And how do we graph negative x squared plus 4? What would the negative do to our parabola? Flip it down. What would the plus 4 do? Move it up 4. So our parabola is going to have a vertex at 0, 4, and go down like that. Our inverse actually has two equations. Our inverse, which we'll graph in black, one equation is when it's positive, and one equation is when the negative's out in front. Yes?
Is the plus 4 inside the radical? Would it move 4 to the left?
Right, so the plus 4 is inside the radical. That's going to move it left or right. Which way is it going to move it? To the right. Now, why is it opposite of what's happening? Isn't the plus supposed to be to the left? Why? You have to factor this one out. Right? We made that special note whenever you have a horizontal stretch, compression, or reflection, and can you see that that negative in front makes a horizontal reflection? In order to do the transformations, you would have to factor it out. So you're right, when you have a plus 4, that normally moves something to the left, but after we factor it out, it becomes x minus 4. That's going to move it to the right. So what does this look like? We're going to have a square root graph. Remember what the square root graph looks like. You're going to flip it over the y-axis and then move it 4 to the right. So this top one, 1, 2, 3, 4, flipped over, then moved 4 to the right, looks like this. The bottom one has 2 flips. You would flip it down, then flip it over, and then move it 4 to the right. And it looks like this. So I used transformations to graph both of those. Can you see that you could have also used your points to graph both of those? What do we know about our original green graph? Our original green graph has 0, 4. It has 1, 3, 2, 0, negative 2, 0. What's going to happen with the inverse? we're going to switch the x and the y values. So instead of 0, 4, can you see that we have the point 4, 0? Instead of 1, 3, we have 3, 1. We have 0, 2 and 0, -2. So we could have found those points as well by just taking our x and y values and flipping them. But I wanted to show you that you could do it with transformations as well. Is the inverse a function? No. The inverse doesn't pass the vertical line test. Now, when we're explaining things or describing things in words, we want to be as clear as possible. I don't know if you noticed I hesitated with the T, and that's why the T kind of looks a little bit messy. I wanted to write, no, it doesn't pass the vertical line test. And just on the last exam, they showed an example where the student used it, and they took a half a mark off for being unclear. Everybody in the room knew what the student was talking about, but on the exam, they wanted it as clear as possible, and using it, they were like, well, we can't be for sure he's not referring to the green graph. How do we know if we're referring to the green or the black graph? So by saying exactly what you mean, the inverse doesn't pass the vertical line test, then we know. So now we've got our sketch, we've got our graph, and it doesn't pass the vertical line test. Okay, questions for this one are 5 and 6. And then I want you just to turn to the bottom of page 239. On the bottom of 239, it says, think further. When is the inverse of a function also a function? When the original function passes the horizontal line test. Can you see in the parabola that we just did that our parabola, the green graph, doesn't pass a horizontal line test? And as soon as you switch x and y's, that will mean your inverse graph is not going to pass the vertical line test. So if your original function passes a horizontal line test, then your inverse is going to be a function because it will pass the vertical line test.